So today we're going to be doing the magic light bulb experiment. What you're going to need is a glass bell jar, 2 alligator clips, 8 D-sized batteries, a roll of electrical tape, a toilet paper tube, scissors, and a mechanical pencil lead refill. So what you want to do first is tape your batteries end to end from positive to negative using your electrical tape. So you're just going to line them up like this and then tape them all together using the electrical tape. You don't need to tape them super thoroughly, just make sure that the positive and negative ends are touching on all the batteries. And then what you want to do is get your toilet paper tube and you want to tape these 2 alligator clips to the opposite sides of the tube so that the clips are facing upwards. Because later we're going to clip the mechanical pencil lead refill between these 2 clips. And then I'm taping the other clip to the other side of the tube. And now what you want to do is carefully clip the lead between the 2 clips. So I'm going to put my glass bell jar over the toilet paper tube carefully, and then I'm going to touch the ends of my alligator clips to the ends of the batteries. As you can see, the mechanical pencil lead is lighting up. So you can test out different ways to see how current electricity flows. You can lift up one alligator clip and demonstrate that in order for electricity to flow through this circuit, you have to have an unbroken loop. So it might be also helpful to explain the roles of conductors, semiconductors, and insulators in this experiment. So conductors are materials that have lots of free electrons, and they allow electricity to flow easily through them. And most metals are conductors. Insulators are materials that have no free electrons and they don't allow electricity to flow at all. So an example would be wood or rubber. So that's why when you're in a car and lightning strikes, you're safe because the rubber tires are insulators and protect you from the electricity. And semiconductors are materials that conduct electricity under specific conditions. So the electrons in semiconductors aren't really free, but they're still loosely attached to their atoms. And when electricity flows through a semiconductor, the movement electrons ends up pulling the atoms as well with high resistance and creates friction and heat. So in this experiment, the alligator clips are conductors, the tape around the batteries, this electrical tape, are insulators, and the pencil lead, which is made of graphite, behaves like a semiconductor. So that's why electricity can flow through it and why it heats up so much. The heat makes the graphite in the pencil lead hot and smoky, but then it moves the atoms so quickly that it starts to light up.